So this week we're going to start off by looking at conics. Okay, that's going to be the first part of the week. And then the last part of the week is chapter 10. That's totally different. That's on systems. Okay, so we're going to just review elimination and substitution, which you've probably done before. So we're going to be looking at conics. The first conic section we are not going to go through, but the other ones we will. So basically, a conic section, think of it as a cross section. If you take a cone and you slice it, and then you look at the shape that it creates when you slice it on the end, those are the conic sections. There are 4. Does anybody know one shape you can get when you take a cone, slice it, and then look at the end, look at the cross section? Yeah? Yeah, if you take a cone and you slice it perfectly straight across, parallel to the base, and you look at the end, you will have a circle. Anybody know another shape you can get? Yeah?
A triangle?
So all the shapes that we get are going to be curved. Okay, they're all curved. Yeah. Yeah.
Kind of like a curved semicircle almost. That's more pointy. Is there a specific shape name?
Yeah, they all have names. Yeah, I think they'd all be names you've heard of before. Yeah. No, they're all curved, and they're all 2D. So pyramid would be 3D. These are all 2D, and they all have curves to them. What if you took a cone and you sliced it on like an angle, going through the sides, and then looked at the shape you'd have? Yeah.
Like an oval?
Yeah, it would be like an oval or an ellipse. It's a little hard to visualize that, but the ellipse is when you slice it on an angle, but you're still going through the side. Circle is when you slice it straight across. Parabola is when you slice it, but you come out the bottom. And the hyperbola is a little different. You actually have to put 2 cones together with the points touching and slice it perfectly straight down. Okay, that's a hyperbola. So the shapes that we're going to look at are a little bit with the circle, a lot with the ellipse and the hyperbola. Parabola, that's going to be the shape that we do not look at, which is fine. You don't need to know the parabola to do the other 2. In fact, the parabola is very different from the ellipse and hyperbola. Ellipse and hyperbola are pretty similar, and circle is pretty similar to an ellipse. Okay, so those are the 4 conic sections. All right, so for each conic section, what I'll do first is I'm going to define it, and then we'll look at a picture of it, and then we'll talk about all the vocabulary that goes with it. So let me start by defining a circle, because a circle is kind of like an ellipse, but it's uniform. It's not like a circle that's been stretched out. If I was going to define a circle, I would say that it's a collection of points, all equidistant from a given point. Right? Like putting a piece of string, put like a nail down, tie a piece of string to it, and then keep the string pulled tight and go all the way around. Every point is equidistant from some point in the center. Okay, that's a circle. The other conic sections are defined similarly, but there's a little bit more to them because they're not as simple as circles. So let's start with an ellipse. So it's a collection of points. In the plane means it's 2D. Okay, all conic sections are a 2-dimensional shape. And it says that it's the collection of points in the plane such that the distances from 2 points added together comes out the same. Okay, so I'm going to show you a picture for what that looks like, and I think it'll help it make more sense. So there's going to be 2 special points inside the ellipse, kind of like this. One here and one there. And if you picked any point on the edge and you measure the distance to that point, and then you measure the distance to that point, whatever those 2 green lines add up to, that's going to be the same thing no matter where you drag that green point around the circle. So if I put a point here, and then measure those two blue lines and add them together, it should come out exactly the same as the green lines added together. And if I put one over here, and I add the red lines up, that should come out exactly the same as the green and the blue. And I can show you that in this picture. So point E is a point that I can drag around the perimeter of the ellipse. And as I do it, I'm going to measure line segment EB and line segment EC. These two lengths are going to change. But the sum of them in this particular ellipse is always 17.3. This one's just 17.3 because of the size. All right. So let me drag point E. So you can see that. I want to move it in grade. No, we need that. What did I grade? So as I drag point E around the circle, you can see that the length of each line segment is changing. But if you add, in that case, 16.1 and 11.2, that's 17.3. Always adds up to 17.3, no matter where you put it. That's the property of an ellipse. And that's how you could draw an ellipse. If you had like a piece of wood or a bulletin board, you put two push pins in it right there. You take a loop of string and you put it over the 2 points that you put in, and you keep it pulled tight, and you go all the way around. That's how you get an ellipse. So it's these 2 fixed points. Versus a circle, it's just 1 fixed point. Okay. So the closer that these 2 points start to get towards each other, the more circular it will become. And when they get right on top of each other, then it is a circle. The further apart you make B and C, the more elliptical the shape gets. Okay, those 2 special points that we were measuring the distance to in this picture up here, those are called the foci. Just a plural of focus. The foci are always inside the ellipse. Okay, and so some other terms we're going to look at. An ellipse has 2 different axes, and I think I go through every one of the things I write down up there. Yeah. So it's got a couple different axes we'll talk about. This is describing what I just wrote as a sentence up there. If you measure the distance from any point to the first focus, and then measure the distance from that point to the second focus, and add them together, it always comes out to a constant. What that constant is can change in different size ellipses. I think in ours it was 17.3 or something like that. Now, if you draw a line through the foci, that is called the major axis. There are 2 different directions the major axis can go. In an ellipse, your major axis can be horizontal or vertical. We will not be drawing an ellipse that's on an angle. It will always be horizontal or vertical. Okay, so we have the major axis. Can you just sign out for me? So the midpoint of the line segment that joins the foci is called the center. So that's foci. Foci. If you find the midpoint of the foci, that's the center. For a lot of the ellipses that we draw at first, the center will be the origin. But eventually we're going to shift the center up, down, left, or right. So that is the center. All right, what else do we have? Okay, the minor axis. Well, the minor axis is through the center, and it is perpendicular to the major axis. Okay, so minor axis in this case goes up and down. Okay, we also have what are called vertices. And the vertices are where the major axis intersects the ellipse. An ellipse always has two vertices. Versus if you think of like a parabola, this point right here, that's the vertex, single vertex. Here we have two. I think I covered everything in that picture. Major axis, minor axis, foci, vertices, center. Yeah. Any questions about any of those terms? Okay. So there are only really two different kinds of ellipses. Either the kind that looks more horizontal, or the kind that looks more vertical. We're going to start out by looking at the kind where the ellipse is more horizontal. When we write the equation of an ellipse, there are three letters that come into play: A, B, and C. Each letter is going to tell you something about the ellipse. And out of those three letters, A, B, and C, two of them are going to be in the equation of the ellipse. All right, so let me start with the equation. So we have x squared over a squared plus y squared over b squared equals 1. If I start scrolling through some of the examples, you're going to notice every equation I write on the board is always going to be equal to 1. If it's not equal to 1, like that one is, that one isn't, we need to make it equal to 1. Okay, so we always want the equation to look just like example 2. Has to be equal to 1. Next thing we'll notice, there's a relationship between A and B. A is always bigger than B. Always. In an ellipse. A is always going to be a bigger number than B. And B is greater than 0. So in other words, A and B are not negative numbers. All right, so what do A, B, and C tell you? Well, I'm going to show you what each one of them mean in a second. But A basically tells you how to find the vertex. C is going to tell you how to find the focus. So if they give you a problem and they tell you something about the focus, they've told you something about how to find C. If they've given you the vertex, they've given you some information that's going to help you find A. So A, if you're looking at it visually, is the distance from the center to the vertex. If your ellipse is horizontal, and that's the center, you're going to have a vertex here and a vertex here. Doesn't matter which one is which, V1, V2. A would be the distance between there and there. And this would also be A, from there to there. So then what would be the distance between V1 and V2? Yep. 2A. Yep. So the length of the ellipse, the long way, is always equal to 2A. So that's why when I wrote this right here, if you're at the center, you go A units to the right and A units to the left. And that's how you get your two vertices. Okay, B. That's the distance from the center to where the minor axis crosses the ellipse. So I had a point up here and a point down there. The distance from there to there is B, and from there to there is B. That's the distance from the center to where the minor axis would hit the ellipse. So what's the width of the ellipse the short way? Yeah, 2B. Yep. So the length of it the long way is 2A, and the length of it the short way is 2B. Now C. C is the distance between the center and the focus. Okay, I'm not going to keep drawing because that picture's kind of got a lot of stuff in it. The focus is somewhere inside the ellipse, like there and there. There's your center. The distance that I just drew in red, that is C. It's the distance from the center to the focus. And that is also C. So if you wanted to know the distance between the two foci, it's 2C. That's the distance between them. Now, they're not always going to give you all that information. Okay? You need to figure out the A, the B, and the C. But you might not know all three letters. You don't need all three. When you are working with an ellipse, as long as you can figure out two of them, you can find the third one. So like in this case, I'm telling you something about C, and I'm telling you something about A. I'm not giving you B. I don't give you anything about the distance from the center to the minor axis. But the problem is, you need B. You're not going to be able to write the equation without it. But that's okay. We can figure out B using this formula. C squared equals A squared minus B squared. Right, so it takes a little bit of practice to get used to working with an ellipse, but once you start, it's not too hard. The hard part is once I show you hyperbolas tomorrow, almost everything is the same between ellipses and hyperbolas, except instead of like a minus here, it turns into a plus. So then remembering which one is which gets a little tricky. But for today, we don't have to think about that. All right, so let's look at an example. It says to find the equation of the ellipse. For now, that is going to be the format that you use. I did say there are two different formats. There's this one, and then I don't know if you noticed the difference, but there's that one. There is a difference if you look carefully at the one in that box and then the one in that box. Anybody see what the difference was? Yeah? Right. Wherever the A is, that tells you the direction of the major axis. A is the bigger number. If A is under X, the major axis is going to be the x. When you put A under y, the major axis is going to be the y. So this kind of parabola is going to go up and down because A is under the y. This kind of parabola will go left and right because the A is under the x. All right, so let's see what we can figure out. Did they give me enough information to figure out A in this case? Yep. Yes, they did. A is the distance from the center to the vertex. You know the center, you know the vertex. Just figure out the distance between those 2 points. And you shouldn't need distance formula or anything like that. You pretty much just count. Okay. What's the distance between the center and the vertex in this case? Yeah, 4. So A is 4. That is one of the numbers that we're going to need in the equation. What other letter did they give me enough information to be able to find? There's only one other letter you can find directly. The other one you have to find indirectly. Yep? C. The distance from the center to the focus. What's the distance between the center and the focus? Yep? 3. Once you got 2 out of 3, you're good. Now we just have to find C. And what's the formula I gave you earlier that connects A, B, and C together? You got to be careful because it kind of looks like Pythagorean theorem, but it's not. Yep?
C squared equals A squared minus B squared.
Yep. C squared equals A squared minus B squared. So we've got 9 equals, A squared is going to be 16 minus B squared. Okay, bring the 16 to the other side, and 9 minus 16 gives me, -7. Now, if you run into imaginaries, something's wrong. You should never get an imaginary answer. And we won't. These negatives are going to cancel. And what's my last step to get B by itself? Yep. Right. And technically, I don't need B by itself because the formula needs B squared. It doesn't need B. B would be helpful if I wanted to actually draw it, okay, which maybe I'll do for the first one. But we want to get B by itself. It will be the square root of 7. Okay, so now we've got everything that we need. We will fill it in to the equation of an ellipse. Anytime you write the equation of ellipse, you can pretty much start out with what I put on the board. That is going to be the same every time. X squared comes first, y squared comes second, 1 is always on the other side. We haven't talked about I showed it to you, but we haven't done the other equation yet. So you know that A has to come first because it's technically the only one I've explained. So A squared first, B squared second. So 16 over 7. And that's the equation of your ellipse. Okay, let's sketch that by hand. Let's take my So A is the distance between the center and the vertex. We have a vertex at -4, 0. Where else do you automatically have another vertex? They come in pairs. Yeah? Yeah. Yeah. Yep. And the length of your ellipse, I gave you a formula for that, it's 2a. So it should be 8 units long. Okay, B, that's the distance between the center and the minor axis. Okay, so B, well, it's square root of 7. It's about probably around 2.4, something like that. 2.6. Okay, so it's 2.6. So that's about here. And right about there. So that's about what your ellipse would look like. Let's see if I can get an ellipse. These are kind of hard to do on the board. Maybe about like that. It's pretty good. Okay. Any question on your ellipse? That's the easiest way to sketch it. Sketch that A and the 2 points for A, 2 points for B, then you've got 4 points and you just make your ellipse from that. All right. Now, if we wanted to sketch that on the calculator, what letter has to be by itself if we want to type that in? Yeah? Y. So first thing I could do is subtract, and I'm going to think of this as 1/16 x squared. So subtract the 1/16 to the other side. What would be my next step to get y by itself? Yeah. Multiply by 7. I'm not even going to do that out. Just leave it. Well, actually, I guess I could because I'll do it as a fraction. So multiply by 7, you get negative 7/16 plus 7. And what would be your last step? Yeah. Take the square root, and remember there are 2 answers. In theory, if we graph that, it should look just like that. It's going to be a top half, and then it's going to be a bottom half, because that fails the vertical line test, so technically I can't draw that using y equals notation. But I can kind of cheat and break it into 2 pieces like that. All right, let's try it and see what happens. So square root of negative, you know what I'm going to do? I'm going to put the negative 7x squared. I'm going to put that all together so then I can just keep it as one fraction. Man, I'm pressing all the wrong buttons. All right, so negative 7x squared divided by 16. Now I need a plus 7. But if I do it like that, I think it would do order of operations okay, but I want to make sure. So I'm going to put in a parenthesis. Like that, and like that. Now, I don't want to have to type that all in again. So now I want to type in the negative of that. So if I press negative, and I go to variables, and I go to y variables, and I go to function, what I can do is type in the negative of y1. If you didn't know that, that's fine. I could type this all in again. I had kind of a hard time. So I'm not going to try typing it in again. I think I have it all now. Okay, so let's draw that and see if it looks like an ellipse. Let's do zoom 6, and then I'll do zoom square to make it. Well, actually, that window looks fine. That looks good enough. There's your ellipse. Okay, so getting y by itself, pretty messy. Generally, we don't like to get y by itself. The only reason I would do that is if I had to graph it. Otherwise, I would leave it exactly like what's in that box. Okay. Any question how I was able to graph that ellipse? try this one. Okay, so this is a different kind of question. In this one, I am giving you the equation. I want you to tell me all about it. Okay. When you have to describe an ellipse, here are the things I would want to know. What is the coordinate of the center? Which way does the major axis go? And if you tell me that, then I automatically know the minor. Okay, so which way does the major axis go? What are the coordinates of my vertices? What are the coordinates of the foci? I think that's it. All right, so whether I give you a bunch of facts and then ask you to write the equation, or I give you the equation and then I ask for all the facts, you always start out with figuring out A, B, and C. You have to get those first. Okay, so what is A in this case? Yeah? 5. Okay. A is defined to be the bigger number, well, A squared. So this is A squared. This is B squared. So A is 5. What's B? Yep. B is always the smaller number, or B squared is the smaller number. That's 3. C, well, that has something to do with what? What does C tell you about? Yeah?
Distance between the center and the foci.
Tells you the distance between the center and each focus. We don't have that information given, so you're not going to be able to find C directly. We need a formula to calculate C. What's the formula to calculate C? Yeah.
Is it C squared equals B squared minus B squared?
Squared minus B squared. So C squared equals 25 minus 9. In this case, C will come out to a nice number. Yeah, 4. C is 4. Okay. So now we've got all the pieces of information. We just got to make sure that we know what each piece of information tells you. Okay. Now, we're going to talk about this more, but I kind of already mentioned it to you. Which way is the major axis going to go in this ellipse? Yep.
Is it horizontal?
Yep, it's horizontal, and besides the fact that's the only equation I've taught you so far, what tells you that it's going to be horizontal? Yep? The A, right? The bigger, wherever A is, look above, and that letter represents the direction the major axis goes. The major axis is the X, left and right. Now, we haven't changed this yet. Every ellipse, up for now, has its center where? Yeah? 0, 0. You'll know when it's not 0, 0 because this and this are going to look a little more complicated. Okay, there's going to be something added or subtracted to the X or the Y, and that's going to shift it left or right, or up or down. Okay, but for now, it's still 0, 0. Okay, which letter here, A, B, or C, is going to help me with the vertices? Yeah? A. A is the distance between the center and the vertex. Now, in our picture, the major axis is horizontal, so we know everything is going to line up like this, left and right. So if you know your center, what's 5 units left and 5 units right of your center? What would be those two coordinates? Yeah.
Zone 0, 5, 0, and negative 1.
5, 0, and negative 5, 0. So you can, yeah, you can write it that way. Because it is at the origin, you could do plus or minus 5, comma 0. That doesn't work when you shift it because the numbers aren't symmetrical anymore. Okay, so we got our vertices. And foci. What letter is going to help us find the foci? Yeah.
C.
C. And what's C in this case?
4.
4. So the foci are 4 units away from the center. And because of this, we know they are left and right, not up and down from the center. So what would be the coordinates of my 2 foci? Yeah.
Negative 4, 0, 4, 0.
Yeah, so I'm going to show you how you can write that one the other way. Negative 4, 0, and 4, 0. Generally, when it says discuss, graph is not part of that. Okay? Graph would be different. They didn't say to graph it. Any questions on how we found any of those 4 things? Okay. So now, let's look at a different equation. So the difference in this one is the a and the b are swapped. X squared's always first, y squared comes second, and you have to have a 1 on the right-hand side. Just like before, a is bigger than b, and b is bigger than 0. C squared still equals a squared minus b squared, no change there. But the difference now is everything is above and below the center. And that's because the major axis is going to go up and down now. So all your important points are on the major axis. Vertices, foci, center. There's 5. 2 vertices, 2 foci, 1 center. Okay, so foci, C units above and below center. Vertices, A units above and below center. Other than that, everything's the same. All right, so let's try looking at this parabola. So first thing I look at is I look at the equation, and I ask myself, is it in kind of the standard form? Okay, think of this box as standard form. Is that equation set up like the one in the box? No. What's wrong with that? That it doesn't look like the one in the box? Yeah.
There's no a or b squared.
Well, we could, if you just make these fractions, you could just pretend like that's a 1 and that's a 1. You know, you could do that. But even if you did that, a and b are not 1 in this case. That would be incorrect to assume that. Yeah.
It doesn't equal 1.
It doesn't equal 1. So that's the first thing we have to do is make it equal to 1. Then you'll be able to look at the denominators for a and b. How are we going to make that equal 1? Yep.
Divide by 9.
Yep. And just make sure we do it here, here, and there. All right. So now it equals 1. We're going to have x squared over what's going to be my denominator if I want to write it like that. Yeah?
1 squared.
1 squared. Yeah. So it's x squared over 1 squared plus y squared over, and again, if we can write it like that, it's going to tell us what a and b are right away. So you could put 9, but it'd be even better if you recognize that it was 3 squared. Again, 9 is not wrong, it's just that's even better. Okay. So now we can identify a, b, and c. And then we can, whatever they want to know from there. Okay. So let's start with a. What's a and b? Yeah.
3.
Yes. A is always the bigger number of the denominators. In this case, this is the denominator for A. What's B? Yep,
1.
1. And C, well, that has to do with the foci. We don't know C, so we got to find that with a formula. What is my formula to find C? Yeah.
C squared equals A squared minus B squared.
C squared equals A squared minus B squared. And there you go. A squared is 9. B squared is 1. 9 minus 1 gives you 8. Take the square root, and that is C. Okay, now we got everything we need. Let's start with the center. What's my center going to be in this one? Yeah?
The origin.
Yep, it's going to be the origin. Just to show you, what does it look like when it's not the origin? It might look something like this. That's what it'll look like when it's not the origin. You're going to start seeing a number either added or subtracted to the x's and the y's, and that's going to shift it. Okay, but you don't have that here. All right, so we got center, major axis. This is important to get right because it's going to tell you if everything is left and right or up and down from the center. So which way does the major axis go in this one? Yeah. Right. The bigger number is under the y, which means the major axis follows the y, up and down. Okay. We now know that everything is above and below the center, not left and right. Okay, vertices. You still will be able to use the plus or minus notation because it hasn't been shifted yet. How far are the vertices from the center? How many units? Yeah.
3.
3 units, and we said 3 units above and 3 units below. What would be the coordinates 3 units above and below my center? Yeah.
0, comma, plus or minus 3.
0, comma, plus or minus 3. And my foci. How far are the foci from the center? Yeah? Do you think you know, Natalie?
Yeah, 0, plus or minus
0. So what letter tells us something about the foci?
1. Oh, C.
C.
0, plus or minus square root of 8.
Yeah, so it's going to be 0, comma, plus or minus square root of 8. Yep. Generally, if the foci or vertices or something doesn't come out to a nice number, we'll just leave it as a square root. Okay. Any questions on how we found any of those? All right, and I'm not going to sketch it on the calculator, but let's do a quick sketch because we haven't done one that's vertical yet. What's the length of this ellipse? The line. What's the length of that? Yeah.
Maybe 6 units.
6 units. So 6 units centered around the origin, going up and down. 1, 2, 3. Okay, so there's the length. And what's the width of the ellipse? Yeah?
2 units.
2 units centered around the origin, left and right. Okay, so there's your ellipse. Let's see if I can get that one way off. Maybe about like that. That's pretty good. Okay, any question on that one? Okay. So we did that one. one. Let's try this one. Find the equation of the ellipse, and they tell me the foci, and they tell me the vertices. Okay. Based on what they're telling me, which two letters, well actually, what haven't they given me that usually I do give you, but even though you don't have it, you can figure it out? Yeah?
Center.
I haven't given you the center, but I did give you two vertices, and we know the center is right in the middle. So if you've got the point, draw our axes. We got a vertex at 0, 3, and we've got a vertex at 0, -3. Where would the center have to be if it's in the middle? Yeah?
0, 0.
0, 0. Yep. Okay. So now you know the center is 0, 0. Which two letters can we figure out now that we know the center? Yeah.
A and B.
Nope, not directly. Yep.
A and C.
A and C, yes. We can find both of those directly. We're going to have to do B indirectly in a minute. Okay. What is A? Yeah. 3. A is center to vertex. How about C? What's the distance from center to focus? Yep.
2.
2. And the formula we need to get B, C squared equals A squared minus B squared. So we get 4 equals 9 minus B squared. And you don't really need B unless you're graphing it. What you really need is B squared. B squared is going to be 5. But if you want to fill it in and put B, you could put square root of 5. You're just going to square that in the next step. All right, so let's start with our equation. It's always two fractions. It's always a plus sign between them. And ellipses are always equal to, yeah, 1. When you're writing an ellipse, what letter always comes first in the top? Yep. X. Squared, y squared. You can always start with that. Okay, we got a sketch up here a little bit. Which way does the major axis go? Yep. Vertically. So that means what letter has to go under? Well, you tell me. What letter has to go under what letter?
A has to go under Y.
The A, which is the bigger number, has to go under Y. And what do we do with the A when we put it under Y?
Square.
Square it. And because we're writing a final answer, you do want to do that out. So we'll make it 9 squared. And what's going to end up under x squared? Final answer. Yep, 5. That's the equation of the ellipse that would meet all those characteristics. Any questions how we got that? Okay. Now, I'm only going to say one thing about a circle, and then we're going to do the last thing with an ellipse, which is shifting it. A circle is really just a special case of an ellipse. If I go back to the picture of an ellipse, all the different things that we looked at, a circle is just an ellipse where two things are the same. What two things would have to be the same in an ellipse, and then it would make it a circle? Yeah?
A squared, B squared.
Yeah, the a squared and the b squared would have to be the same, which means the major axis is equal to the length of the minor axis. If those two things are the same, then you have a circle. All right. So, a circle is just a case where the a and the b are the same. Well, if the a and the b are the same, then you don't need two different letters in the bottom. You can just use the same letter twice, like a squared and a squared, because they're the same. Now, when we write the equation of a circle, normally they don't write it with fractions. How could I get rid of my fractions in this case? Yeah.
You multiply everything by a squared.
Yep, you can multiply everything by a squared, and you would get that. So when you write the equation of a circle, generally it's not equal to 1. That's not how they do it. They do it like that. And what do you think this a is? That's the equation of a circle. Yeah?
The radius.
It is the radius. Yep. Normally I would use r there, but since we're talking about conics, we don't use the letter r in the original denominators, so I stuck with the letter we were using. So x squared plus y squared equals a squared. That's the equation of a circle. So a circle, just a special ellipse. That's all it really is. And that's all I'm going to say about circles. Okay, so the last thing with an ellipse is shifting. Up until now, we've been working with 3 letters, A, B, and C. Now we're going to work with 5 letters, A, B, C, H, K. The A, the B, and the C still mean exactly the same thing as they did before. So A is the distance from center to vertex. B, center to minor axis. And C, center to focus. None of that is going to change. What the H and the K represent is the coordinates of the center. H is the x coordinate. H represents the x value. K represents the y value. So now your equation looks like that. It's the exact same equation I gave you before. Just replace x with x minus h. Replace y with y minus k. A is still bigger than b. C squared still equals a squared minus b squared. None of that's going to change. In the first one, because the bigger number is a, and that's under the x, that means the major axis goes on the horizontal. The second one, I put the bigger number under the y. That's going to make the major axis go vertical. Now, if you look in the book, there's a whole table that kind of explains and gives you all these formulas for how you can figure out the vertices and just memorize formulas, but you don't really need to memorize anything. As long as you know what the A, B, and C are, and you know the center, you just have to count how many units away from the center you need to be for your vertex and your focus. Up and down if it's vertical, left and right if it's horizontal. Okay, let's try this one. So this one says, find the equation of the ellipse. All right, so 5 things we want to do off to the side. H, K, A, B, C. All right. Anyone think they can tell me one of those letters without too much work? H is 2. Yep. So when we start writing the formula, we got to figure out if it's the top one or the bottom one, but we are going to fill in a 2 for H. Okay, how about another letter? Yeah? K is -3. And that came from these two numbers right here. H, K. All right. What's another letter there that we've got enough information to figure out? Yeah?
A.
Yeah, we can definitely figure out A. A is the distance between the center and the vertex. What's the distance between this point and that point? Yeah,
3.
A is 3. Yep. Okay, and you're only going to have enough information for one more letter. You're going to find the third one indirectly. What's the other letter we can find? Yeah.
C.
C. And C is, can you just tell me what C is?
The distance between the center and the focus.
Center to focus. What's the distance between the center and the focus?
1.
1. And to find B, we're going to use the formula, C squared equals A squared minus B squared. C squared, A squared minus B squared. Okay, so B will come out to how much? Yeah.
The square root of 8.
Yep, square root of 8. Perfect. All right, so now we've got all the information, but we don't know, are we left and right, or are we up and down from the center? Okay. That's going to tell us which one of these equations. If you're not sure, graph the points they gave you and see how they line up. Do they line up horizontal or do they line up vertical? Okay. It doesn't have to be exact because we're not really sketching in this problem, just to kind of help us. So we've got right 2, down 3, right 3, down 3, right 5, down 3. Which way does the major axis go in this problem? Yep.
Vertical.
Vertical, which means you need to put, out of the A and the B, you need to put A under the letter that would make it vertical. So put it under the Y. All right, so here's everything we can start out with. X minus something, Y minus something equals 1. In our equation, doesn't matter which one we use, which one always goes with X? Yep.
I just have a question. Isn't it horizontal, not vertical?
The major axis?
Yeah. It's the x values that are changing, not the y.
So, did I graph these wrong? Right 2 down 3, right 3 down 3, right, oh yeah. I don't think I graphed those right. Thank you. Let's learn how to graph. So right 2 down 3, right 3 down 3, and then right 5 down 3. Yeah. Yeah. So it is horizontal. All right. So since it's horizontal, what letter do we want to put A under? Or technically A squared. Yep. X. So we want that there. If A squared is under X, what squared do we want under Y? Yeah?
B.
B. And what's B squared?
8.
8. So just barely an ellipse. These are almost the same numbers. So this one would look pretty circular if you drew it. All right. Now, what letter do you always put with X? It's either the H or the K, and it never changes. Yeah. It's always the H. So it's X minus H. And what letter always goes with the Y? Yeah? K. K is -3. And we can just clean that up a little bit. My numerator over here, plus 3. And that's the equation of the ellipse that fits all the conditions. Did I make another mistake?
Yes.
Yeah?
The x minus 2 and the y plus 3 should be in parentheses squared.
Oh, yeah, yeah, we gotta keep squaring those. Thank you. Yeah, if you don't square them, then it would be linear. Yeah, be a straight, just be a line. All right, so that's ellipse. Any questions on that equation? So tomorrow, when we do the hyperbola, we're still going to be working with these same 5 letters again, A, B, C, H, and K. It's just little things are going to change. Like that becomes a plus, that becomes a minus. So then we just have to keep them straight. Okay, so exactly like this again tomorrow. All right. So I do need to adjust that. So this is from a different book. So if you notice that the section looks a little different than your book, that's fine. The PDF that's online is correct. Actually, I can simplify that. 39 to 45. Just do it that way. So I took out 47. So make sure if you do look at the video, the one on Schoology probably has 47, but we're gonna skip that. Okay, 13 through 17, a lot of that is matching. So there is some matching in the homework as well. Okay, so we'll take a look at that first thing tomorrow.